Hello everyone, myself Sita chettri, having roll number 21NS0158, BSc 3rd semester, Ranchi Government College. And today I'm going to present my presentation for Sectional B examination on the topic Ultraviolet Visible Diffuse Reflectance Spectroscopy, which we also called UV-DRS or UV-DRS. Now let's get started with the topic. These are my content, starting with introduction, principle, diagram or the DRS instrument, theory, application, conclusion, and lastly reference. Now let us discuss what is UV-DRS. UV-DRS is the ultraviolet visible diffuse reflectance spectroscopy, which is a surface analytical technique which is widely used for the analysis of powders and surfaces requiring a negligible sample preparation. It uses ultraviolet, visible or infrared light as a probing medium. A reflectance spectrum is obtained by the collection and analysis of surface reflected electromagnetic radiation as a function of frequency, which is usually in wavelength centimeter inverse, or wavelength, which is in nanometer. Two different types of reflection can occur: regular or specular reflection, usually associated with reflection from smooth, polished surfaces like mirror, and diffuse reflection associated with reflection from so-called matte or dull surfaces or rough surfaces texture like powders. In diffuse reflectance spectroscopy, electromagnetic radiation reflected from dull surface is collected and analyzed. DRS technique is mainly used for acquiring IR spectra of powders and rough surface solids such as coal, papers, etc. Now let us see the principle of UV-DRS. Diffuse reflectance spectroscopy is a well-established technique for studying the spectral characteristics of opaque solid samples based on the principle that not only does light reflected from the material come from the surface, that is specular reflection, but some are reflected internally, that is diffuse reflectance. Reflectance spectroscopy is very closely related to UV-VIS spectroscopy, which means ultraviolet visible spectroscopy, in that both of these techniques use visible light. UV-DRS, which we sometimes call drifts, which means diffuse reflectance infrared Fourier transformation spectroscopy. The IR beam is reflected and dispersed on the matte surface of the sample. Thus, emerging radiation leaves the sample in all directions, but with appropriate optical setups is directed towards the detector. This is the diagram of types of reflected light, which is of two types, specular and diffuse reflected light, as you can see here in the diagram. This is the UV-DRS instrument, as you can see here in the screen. Now let us discuss the theory of UV-DRS technique. Fresnel and Kubelka-Munch reflectance. The concept of specular and diffuse reflectance has been precisely discussed in the above section. The optical phenomena resulting in diffuse reflectance are many and complex. Far from a comprehensive treatment will be given here, and you can see the diagram below. The above figure systematically shows the some phenomena involved in a diffuse reflectance experiment. Now, let us consider the sample as a randomly distributed powder. The incoming radiation can undergo specular reflection from the individual particles. The first theoretical treatment to explain the phenomena of diffuse reflectance was given by Borger. It was assumed that diffuse reflectance occurs from specular reflection from elementary mirror of the sample surfaces with planes statistically distributed at all angles. Specular reflection can thus further differentiated into diffuse Fresnel reflection and specular Fresnel reflectance. Since the individual sample particles' surfaces are randomly distributed, surface of the particle is not necessarily parallel with the macroscopic sample surface. So, although the radiation reflected from the such surface undergoes specular reflection, that is, angle of incidence equals to angle of reflection, the reflected radiation appears diffuse with respect to the macroscopic sample surface. Therefore, we have the term Fresnel reflection in the theory, and this is the formula below. Now, let us discuss the application of UV-DRS. Number 1 is diffuse reflectance UV visible spectroscopy. Diffuse reflectance UV visible spectroscopy is mostly used in the applied sciences for the analysis of dyestuffs, printing, inks, paints and pigments and paper and so on. Number 2, for color matching analysis, visible diffuse reflectance spectroscopy is used for denture materials, tiles, cosmetics and medicinal tablets, etc. Application number 2, diffuse reflectance near-infrared spectroscopy. Near-infrared reflectance spectroscopy has become an accepted tool for monitoring many industrial processes because it is fast, involves little sample preparation, is non-destructive and can perform multi-component analysis. Absorption of radiation in the near region results predominantly from vibration of light atoms with strong bonds. The near-infrared literature abounds with various statistical analyses of data sets such as partial least squares, principal compounds analysis, multiple linear regression, and neural networks. Application number 3, diffuse reflectance mid-infrared spectroscopy. The diffuse reflectance mid-infrared spectroscopy has a major contribution towards the creation of drift techniques. Now let us discuss the application of drifts, which is diffuse reflectance infrared Fourier transformation spectroscopy, which I have already mentioned in the earlier slides. Undoubtedly, the most widely used application of drifts not to be found in the literature is the rapid identification of powders with little or no sample preparation. Now, drift as a chromatographic detector. Drift can be used as a detector for species separated by thin layer chromatography, that is TLCIR. Now let us see drifts in surface science and heterogeneous catalysis. Drift is becoming the single most important technique for studying the surface chemistry of light surface area powders. Drift is most useful for the determination of clay, mineralogy and organic matter. polymer studies is also done. Now let us see the conclusion of UV-DRS technique. Diffuse reflectance is a technique that is widely applied from UV to the mid-infrared spectral region. DRS is mostly radially applicable to powders. Any sample that scatters radiation can be characterized using this technique. And this is all about the UV-DRS technique. And these are my references. Thank you.